Artificial blood, sci-fi breakthrough, or false hope? The concept of artificial blood has long captured the imagination of both scientists and the public, often portrayed in science fiction as a miraculous substitute for human blood, able to save lives without the need for donors. But how close are we to turning this futuristic vision into a clinical reality? And is artificial blood truly a breakthrough, or is it still a false hope? What is artificial blood? Artificial blood refers to substances developed to mimic and fulfill some functions of biological blood, particularly oxygen transport. Unlike whole blood, artificial blood typically doesn't include cells like red or white blood cells or platelets. The main goals are delivering oxygen to tissues, acting as a temporary substitute in emergencies, reducing dependence on human donors. There are two primary types. 1. Hemoglobin-based oxygen carriers, HBS, derived from purified hemoglobin. 2. Perfluorocarbon-based PFCs, synthetic molecules that dissolve and carry oxygen. Potential benefits. 1. Universal compatibility, no need for blood typing or cross-matching. 2. Longer shelf life, often stable at room temperature for months or years. 3. Safe from infections, no risk of transmitting HIV, hepatitis, or other pathogens. 4. Rapid deployment, useful in remote areas, battlefields, or disaster zones. 5. Support in blood shortages, can alleviate strain on blood banks. Scientific progress in clinical trials research has spanned decades. Some notable developments include Hemopure, bovine hemoglobin-based, has been used in South Africa and Russia. Polyheme and Oxycyte showed promise in trials but faced safety and regulatory setbacks. Stem cell-derived red blood cells are being explored but are expensive and complex to produce. Despite these efforts, no artificial blood product is fully approved for widespread human use in the US or Europe. Challenges and risks. 1. Toxicity and side effects. Some products cause vasoconstriction, kidney damage, or immune reactions. 2. Limited functionality. Current formulations may carry oxygen but lack immune and clotting functions. 3. Cost and scalability. Mass production remains expensive and technically demanding. 4. Regulatory hurdles. Strict safety requirements slow down approval processes. The verdict: breakthrough or false hope? Breakthrough? Yes, in concept and select emergency uses, especially for military or extreme environments. False hope? Potentially if expectations are unrealistic, or if the goal is to completely replace donor blood in all clinical settings. Conclusion: artificial blood is not yet a complete substitute, but it represents an important scientific frontier. It's a partial breakthrough with real potential, particularly as a stopgap in crises, but not a universal solution. Continued investment, ethical testing, and regulatory support are critical for realizing its full promise. Thank you. Have a nice day.